Another really important part for good-looking user interfaces are images. In tkinter, you can add images to some widgets. Labels, buttons, and canvas is what you're going to use most of the time. That being said, for images that scale properly, you will need to create the logic yourself. So the scaling logic doesn't come with tkinter. That is something you have to make yourself. On that note, what I haven't mentioned yet, what we're going to create is going to be this one here. We have two buttons, one with TTK and one with custom tkinter, and then we have a raccoon, and this raccoon we can scale, and it's always going to cover the appropriate area. This kind of logic you have to make yourself. It doesn't work by default. Now, before we can do all of this, we have to do one more thing, and that is we always need the Pillow library to use images. Pillow is the default Python image library. This one you have to install on your own first of all. This you do either with the PowerShell or with the terminal. In my case, this is the PowerShell. What you have to type is pip install pillow. This is going to install quite a few things. Obviously, if you're on a Mac and using terminal, this would be pip free install pillow. Once you have that, we can start working on some code. For the starting setup, I am importing tkinter and ttk. On top of that, I am importing custom tkinter. We are going to use both because they have slightly different setups for importing images. After that, we are creating the basic tkinter window, and then we are running the main loop. The end result is going to be a basic window. Before we can start properly, we have to do one more thing, and that is we want from pil import image and image tk. Pil is the pillow we just installed. For some reason, the import here is a different name compared to the import in the PowerShell or the terminal. PIL stands for Python Image Library, and somehow thought it'd be cute to call it pillow. I don't understand it either, it's quite weird, but this is how you would import it. Inside of pillow, you have one really important object, and that is called image. You basically always use that one. And image has a custom tkinter variant that is called image tk. On that note, I have made a really long tutorial on Pillow itself. It's on YouTube, you can watch it for free. You can use Pillow for all sorts of things, like scaling images, changing colors, adding text, and, well, lots of other things. So check it out if you are interested. Although for this video, I just want to import an image. To make that work, first of all, I need to cover our folder structure. Right now, I have one folder, and this folder contains the code. The code file here is called images. In this folder, I have three more images. I have Python dark, Python light, and raccoon. Those are the images I want to import. For the import, first of all, we need to import the image itself. So image, let's call it original. This we get with image.open. And now we need the file path. Since I want to import, let's start with the raccoon. I want to import raccoon, and the file ending here is JPEG. With that, we have an image. So I can run the code. We're not getting an error. That's looking pretty good. Now I have to figure out how to get this image on a widget. For that, first of all, we need a widget. To get started, I just want to create a label. And this can be ttk label. The parent is going to be window. The text could be, let's go with raccoon, and let's pack the label. There we go, we have raccoon. A label can also take an image. Although what we cannot do is simply pass in the original image in there. We will get an error that the image specification must contain an odd number of elements. I don't know what that specifically means, but basically what tkinter wants is an image tk, not an image. We can account for that quite easily. I want to store this in another variable. I'll call it image tk. This image tk we create with image tk dot photo image. You only need one argument. That is the image original. With that, we can pass in image tk into the image, and it should be working. There we go. The problem we have right now is that the image is way too large. For reference, the raccoon has a size of 6000 by 4000, while our window is only 600 by 400. So we can only see a very small part of this window right now. but we can resize the image. This we do when we are importing the image. This image here is returning an image object. This image object has a couple of methods. The one we care about right now is called resize. Resize wants a tuple with a new size and a new width. Let's say for now, I want to cover the entire window with the image. This would be 600 by 400. With that, we have the raccoon covering the entire image. Although, if I resize the window, this breaks quite fast. But at the very least, we do have a start. Unfortunately though, you basically never want to use an image inside of a label, for the simple reason that you cannot resize the image if the window changes. You always have the same image size depending on what you get from here. To change that, you need quite a bit more logic, so I am going to cover that later on. Let me get rid of the resize and comment out the label. Running this again, we have a plain window, but we do have an imported image. Before I explain the logic on how to use images, I want to cover buttons, because buttons are very easily usable with images. Let's say I want to create a button. This is going to be ttk.button. The parent here is going to be the window, and for text we can go with a button. This button I want to pack right away. Now we have a button. This button can also accept an image. I could add image tk. Now we have the raccoon again, but remember the raccoon is way too large. But the raccoon is not what I want to add to this button. Instead, I want to import a different image. That image is going to be python-dark, which we get with image.open. The name of the file is called python_dark.png. Important here, we have a different file ending, because Python-dark has alpha values, so we need a PNG. This once again, we have to convert. Let me call it python-dark.tk. For that, we need all of this. I can simply copy it like so and paste in python-dark. This python-dark.tk I now want to use for the button, like so. And this is still way too large, although I guess a little bit better. Since the button isn't going to change size, for this one, it is fine to simply resize the button here, and then you don't have to worry about it anymore. In my case, I want to resize the button to a size of, let's go with 30 by 30. Now we have a button with a Python logo. To see the text again, we need a compound argument. If I, for example, set right here, we now have a button and then the logo to the right. This can also be left. And then we have the image to the left of the button. For a bit more spacing, you could do a tiny bit of a hack here and simply add some spaces for the button. And now you get a bit more spacing between the two. However, if I duplicate all of this and change the button to, let me call it a button CTK, because I want to create ctk.ctk button. For that one, we are getting an error. That photo image object has no attribute create scaled photo image. Once again, I'm not quite sure what that means, but the concept you have to understand is that you couldn't use an image tk, this one here, inside of a CTK widget. Instead, what you would need to do is create a separate CTK image. This you get with CTK and CTK image. This is what you have to pass into a CTK widget if you want to have images. I'm going to store this one in an image CTK variable. The reason why this is different is because for custom tkinter, we always need a light image and we need a dark image. Those we have to import separately, but other than that, we are using it the same way. How you usually want to do this? Let me put it over multiple lines actually. What you can do with the import here is simply use image open as the argument. For example, I could paste image open Python dark in here, and then for the dark theme, I want to have Python light. This might look confusing here. Basically, you want the dark image for the light theme and the light image for the dark theme. For the simple reason that light image has a light background, so you want to have a dark image. And then the other way around is going to work the same. With that, we have an image CTK, and this is what you want to pass into this image. Now I can run this, and there we go. We have a Python logo for a button that is bright right now. If you were using custom tkinter and had a light and a dark theme, this would also cover the dark theme. Although since I am using tkinter by itself, this isn't really applicable, but it would definitely work. With that, we can actually cover how to use tkinter with images. The major problem that you have in tkinter with images is that images do not scale by default. We could have as large or as small of a window or any kind of container. The image, unless you add some custom code, is not going to update, which would break any kind of layout really fast. To account for that, we have to add an image to a canvas and then use the canvas dimension to update the size of the image. That we can do in real time, although we have to figure out a few mathy things in here. It's not going to be too bad. Although once we have that, we can add an image to a container and always make the image scale to that container. And before I start, I want to create a different kind of layout. I want to have a grid where those two buttons are on the left, and then on the right we have the actual image. For that, I'm going to put it up here. I want to create a grid layout. I want to get window.column configure. In here, I want to have 0, 1, 2, 3, in total 4 columns that all have a weight of 1, and I want them to be uniform. Like so. So uniform is equal to A. Besides that, I only want to have one row. So row is just going to be 0. Uniform, we can just ignore for that. The image imports can stay the same, although for the buttons, we have to update them because we're using pack, but now we have a grid. As a consequence, I want to put both buttons inside of a frame. I'm going to call this button frame, and this is ttk.frame with the window as the parent. Both of the buttons are going to be mastered to this button frame. Finally, I want to place the button frame using the grid method. I want column to be 0. I want the row to be 0. And then I want to have sticky with north, south, east, and west. If I run this again now, there we go. We have the two buttons all the way in the top left. I think to make this look a tiny bit nicer, we can give both a bit of vertical padding, let's say 10 pixels. Now there's a bit of space between the two. With that, I can create the canvas for the image. This is simply going to be a canvas, so tk.canvas. The parent is going to be the window, and for now, this is all we are going to need. This canvas I want to place right away. Canvas.grid. This is going to be column 1. Column span is going to be 3. We are covering all of the remaining columns. Finally, row is going to be 0. Also, I want this to be sticky to all 4 sides. If I run this now, we can't see anything because we don't have a background color, which I can change quite easily. Background, let's set it to red. And there we go. Now we can see the canvas itself. However, the canvas doesn't cover everything perfectly. For example, at the bottom here, we have this very thin line. Same on the right side, and we would have the same on this side and this side as well. This we have because of the border of the canvas. We can get rid of it though. All we have to do is set BD to 0. Then we need highlight thickness and set this to 0 as well. Finally, the relief should be rich. With these numbers, the canvas is now going to cover the entire area and we have no border. Also, let me set this to black so it looks a bit better. There we go. On this canvas, we can now add an image. This we do with canvas.createImage. For the arguments here, we need an X and a Y position. I'm going to set it to 0 and 0, which is the top left. And then we need an image. This needs to be a TK image, which in my case, for the raccoon, I have image TK. Image TK. Now if I run this, we can see one eye of the raccoon. What we could also do in here is set the anchor. By default, we're placing the center anchor like this, but I want to place the northwest. Now we can see the top part of the image again, but it doesn't do very much. The way you have to think about it is that the entire image starts here and then goes really, really wide to the right and to the bottom. I believe the numbers were 6 by 4, 1000. So much larger than our window. To account for that, we have to dynamically resize the image. I don't want to create the image right away. Instead, I want to do all of this inside of a function. This function I'm going to trigger every time we are changing the size of the window. This we get with canvas.bind. In here, we need configure. This is going to trigger every time the size of the canvas changes. If that changes, I want to run a function. The simplest for the image is stretch image. You're going to see in a second what this one is going to do. But let me create it first of all the way at the top. I want to create stretch image. In here, since we are working with an event, we need one default argument, and that is the event. What we are going to do in here is we are going to get the size of the canvas, and then we are going to scale the image to that size. Finally, then we can actually place the image. For that though, first of all, we need to get the window size, or more specifically, let me call it size. We want to get the width and we want to get the height. The width is going to be event.width and the height is going to be event.height. If I print both of those numbers, we have width and we have height. Now if I run this, we are calling this function, and if I resize the image, we get updated numbers. So this is working quite well. Just to make sure, now the thing is really narrow and very, very small, but now it's much larger, so the numbers seem to be pretty accurate. These numbers we can now use to create an image. Although what is really important, you already want to have one image imported, and you only resize it when you resize the entire window. You do not want to re-import the image every single time you are resizing the window. That would be really inefficient. In my case though, I already have one image imported. This is what I want to work with. I want to store all of this inside of a new variable. I'm going to call this resized image. We need the image original and then resize it. Since resize wants to have a tuple with a width and a height, this is quite easy because we already have width and height. Although this is still just an image, but we need an image tk. We need another variable, let me call it resized tk. This is going to be image tk.photo image, the same thing I have done down here, except now the one argument is going to be the resized image. Finally, this we can place on the canvas. For that, all we need is canvas.create image. The start position here is going to be 0 and 0. The image I want to place is resized tk. Finally, the anchor is going to be northwest. Now if I run this, we only get a black background color. So something didn't go well. The problem is that the image tk, this line here, always has to be in the same scope as the main loop, or wherever you call it. In our case, an easy fix here would be to set resized tk as a global variable. Resized tk, and now we can see the raccoon. So just to reiterate, we have our window in the global scope, and we are also calling window.mainLoop in the global scope. Because of that, the image tk needs to be in the global scope as well. They always have to be in the same, and once again, I have no idea why. But with that, we have the image of a raccoon, and if I resize the window, the raccoon resizes with it, because we are updating the size of the window every single time we're updating the canvas. Which is working, but you can see a limitation here. We are stretching the raccoon quite a bit. To account for that, I want to create a second function. I'm going to call this one fill image. This one is not going to resize the image. Instead, we are going to fill the entire image and we're going to cut off parts of the image that don't fit. What we are going to do for this one, let me explain it first before I create a function. Let's say this one here is the canvas and the image might be as large as this bit here. Inside of this function, if the image is larger than the canvas, we're going to cut off this bit and this bit. That way, the raccoon is going to keep the same aspect ratio. Later on, we will create a third function that will keep the raccoon always inside of the canvas. But for now, let's fill the entire canvas. For that, once again, the one parameter I need is the event. I want to have global resized tk. Now, in here, we first of all need to get the current ratio of the event. Or of the canvas, the same thing. This we get, I want to store it in a variable, canvas ratio. All we need here is event.width divided by event.height. This number is really important, and we need it both for the canvas and we need it for the image we have imported, this image here. This we can also get quite easily. I want to store it in a variable, let me call it image ratio. To get the width and the height, we need image original.size. This is returning a tuple with the width and the height, which means the width is going to be 0. And this I want to divide by the height, so size 1. If I print all of this, image ratio, this one, we get 1.5. That number we get if I open the folder again. The raccoon has a size of 6000 by 4000 pixels. Dividing 6000 by 4000 gets us 1.5. This number is really important because it tells us how we are going to scale the image itself. For some context here, let me do all of this actually on a separate surface. Imagine we have a perfect square where all sides are 1. If that was the case and we would divide the width by the height, we would get 1. This is telling us that we have a perfect square. If we have some kind of rectangle with a width of 2 and a height of 1, in that case, we would divide 2 by 1, which would give us 2. Which tells us that the larger that this number gets, the wider the entire thing is. By the same logic, if we have a really narrow container, something like this, where we have a height of 1 and a width of 0.5, that is a horrible 5, 0.5, then we would do 0.5 divided by 1, which would be 0.5, which means the smaller this ratio becomes, the more narrow our container is going to be. This applies both to the canvas and to the image itself. This information we can use. So in our case, we know the ratio of the image and of the canvas. What we want to do, imagine this one here is the canvas, or C in short. This we want to compare with the image itself, or the aspect ratio of the image. Let's say this could be something like this. This would be I for image. If the canvas has an aspect ratio of, let's say, 1.8, with the image having an aspect ratio of 1.5, we know that the canvas is wider than the image. If that is the case, I want to scale the width of the image to the width of the canvas, which right now would simply stretch out the image. So this wouldn't be particularly useful. However, since I know the aspect ratio of the image, I can simply use the width and then combine it with the aspect ratio to get a new height of this image. Even if I resize the entire canvas, I would fill the entire width and then the top and the bottom part of the raccoon, so the parts that are outside of the image, are simply going to be cut off. I hope all of this makes sense. The math here isn't particularly difficult, but you have to get your head around it. I think if I implement all of this, this is going to make a bit more sense. What I really want to figure out is I want to get the coordinates of my image. Which means ultimately I want to get a width for the image and I want to get the height of the image. Although for these images, first of all, I want to know if the canvas ratio is greater than the image ratio. If that is the case, we know that the canvas is wider than the image. If that is the case, I want the width of the image to be the event width. That way, we are filling the entire width of the canvas. There's one thing that tkinter is a bit fussy here, and that is that we always need to have integers. A very easy thing to account for. Once we have that width, let's say for some imaginary numbers, the width of the canvas could be 800. On top of that, we know that the image ratio is 1.5. These two numbers we can now use to calculate the new height of the image. All we have to do for that is rearrange this formula here. Initially, we got the canvas ratio, but now we want to have the height, this height here. This we get by getting event.width, or the width of the image itself, this width here, and then divided by the image ratio. This also needs to be an integer. Let me remove the white space. This information we can now use, because with that we can create a resized image, which is going to be the image original, and then I want to resize it with the width and the height. After that, we can create a resized tk, which is just going to be image tk.photo image with the resized image. Finally, there's one more thing we have to cover. We still want to get canvas and create image. Although now, for the X and the Y position, we want to place the image right in the middle of the canvas. All we really have to do is get event.width, that is the width of the canvas, and divide it by 2. tkinter, or the canvas more specifically, wants to have an integer. This we can do again for the Y position. I simply want to divide the height of the canvas by 2. Finally, besides that, I want to set an anchor. The anchor is going to be the center. Once we have all of that, ideally over multiple lines, so it's easier to read, we can place the image itself. The image is going to be resized tk. Now if I run this, we can see the raccoon, and the raccoon scales with the canvas, because I forgot to actually call fill image whenever we are resizing all of this. Now, if I run all of this again, we are getting an error because by default, this if statement here is not true. To account for that, let me change it to else with width being 1 and height being 1 as well. So we get at least something. With that, we can't see anything. However, if I make this less tall, there we go. We can now see the raccoon at least under certain aspect ratios. But if I make this smaller, at some point it disappears. That happens because this if condition doesn't apply anymore, because in the else statement, the canvas is narrower than the image. This is what we have to account for as well. For that, let me copy the width and the height. Now I need these numbers here. For this one, we now want to have the image cover the entire height of the canvas, which means the height is simply going to be the event.height. For the width, I want to get the height once again and multiply this with the image ratio. This should be multiply, not plus. With that, all of this should be working. Now we can see the raccoon, and the raccoon works just fine. We are never scaling this one. We are simply cutting off parts that are outside of the canvas. This is looking pretty good. For the math here, if you really want to understand this, I would recommend to go over this a couple of times. Basically, you always want to imagine that you are scaling a canvas and then you are fitting an image inside of it. When you're hearing this the first time, it can be quite confusing, so definitely go over this in your own time. The math really isn't hard, it's just some logic that you have to grasp. With that, we are nearly done. There's one more thing that I want to do. In this case, the raccoon is always going to be fully visible, and we are scaling it in such a way that we never cut off anything, but the aspect ratio itself stays identical. This is going to be reasonably similar compared to what we have done here with fill image, which means it's going to be your exercise. I want you guys to create a third scaling behavior to always show the full image without cutting off parts. Pause the video now and try to figure this one out. You can reuse a lot of this. Since I am going to reuse quite a bit, I am simply going to copy the entire function, paste it in here, and rename it to show full image. This function I want to call right away. Down here, instead of configure, I want to show the full image. Inside of the function, global can stay the same, the current ratio we also need, and all of the stuff down here is also going to stay identical. which means the only part we have to change is this bit here. Specifically, we have to get new numbers for the width and the height for all aspect ratios. The way you have to think about this one, we once again check if the canvas ratio is larger than the image ratio, which means that the canvas is wider than the image. For example, if this one here is the canvas, the image would be something like this. What we have done before is we have scaled the width of the image to here and then used that number to calculate the new height of the image. This I want to change now. Instead, what I want to do to show the entire image, I want to scale the height to only be as tall as the canvas itself. This number I am then going to use to calculate the width of the image. Which means, for this one, I want to have a new height. The height is simply going to be event.height, with the width simply being the height multiplied by the image ratio. We can try this one right away. If it's like this, we have the entire image, but now if I go even further, now we have a black background. And we can see the entire raccoon, which only leaves us the last bit here. For this one, I want to start with the width, because now the canvas is narrower than the image. In this case, the width is going to be the event.width. For the height, I want to get the width and divide it by the image ratio. That should be all we need. With that, we have the entire raccoon, and we can always see the entire raccoon regardless of aspect ratio, and, well, the raccoon updates automatically. This image in all of its forms, so these three functions, work slightly differently. But once you have them, you can place the canvas in any kind of container and the size would always scale. That way you can use the image wherever you want, which is what makes it actually useful.